Hi, and this is section 5-6, which is called Fitting a Line to Data. And you need to be on page 325. You might want to stop the video right now. Please go to your book, page 325. To fit a line to data, there's a few things we have to know and be able to do. And the first of those is to be able to identify a positive, negative, or no correlation when we have a scatter plot. So please look at the top of page 325 and you'll see a picture of each of these relationships. Now, I guess a couple of vocabulary words that I should talk about as we go through this. The first of which is scatter plot. Now, you've made scatter plots throughout the year. A scatter plot is just taking individual points and plotting them on graph paper. We've graphed individual points on graph paper many times this year. Each time we did that, that would be creating a scatter plot. Now, when we have a scatter plot, there can be a relationship to the points we plot. If you look at the top of page 325 on the far left picture, you see a picture where we have a set of points, and they look like it looks like those points are rising from left to right. In fact, you see a line drawn through those points which kind of describes what those points are doing. That is called a positive correlation. When your points are rising in some similar pattern like these points are, and we can draw a line to represent that pattern, that's a positive correlation. In the middle picture at the top of page 325, this would be an example of a negative correlation. You can see that our scatter plot, the points seem to be falling from left to right. That's called a negative correlation. In fact, they drew a line which represents that drop. And then the far right picture, when there's just a scattering of points on a graph and no apparent pattern, that's called no correlation. So there's three types of things that can happen when you have a scatter plot. You can have a positive correlation, you can have a negative correlation, or you could have no correlation. So maybe I'll just label those. You can have three things: a positive correlation, a negative correlation, or no correlation. I think the easiest way to walk you through fitting a line to data and finding the correlation would be just to walk through a couple of your homework problems. So, I'm going to have you do two things. First of all, look at page 326, and it says at the very bottom of page 326 for your notebook, it might not be a bad idea to write these quickly in your notebook. When you are asked to fit a line to model data or fit a line to data, you have to do four things, okay? And the four things are as follows. Number one, you make a scatter plot. You make a scatter plot of your data. That's the first thing. We'll do this together in a minute. Number two, you decide if there's a correlation. Got to spell that right. You decide if there's a correlation, and then if there is, draw a line of best fit. Okay, and I'll just put down if there is a correlation. We draw a line of best fit. And finally, to wrap things up, we would write an equation. Write an equation of that line. Okay? And remember, if it's a line, you can write that equation in slope-intercept form like we did in the beginning of Chapter 5 in sections 5.1 and 5.2. Okay? So let's actually do that. I'm going to do two sample problems from your homework with you, and we're going to walk through these steps. Okay? So first of all, let's go to problem 6. Problem 6 says to make a scatter plot of the data in the table, draw a line of fit, write the equation of the line. So before we start graphing this out, and you're going to have graph paper, the first thing is we got to pick an appropriate scale. If we just start blindly graphing points, now here's a problem. If you just start graphing points and you don't think about your scale, look at the end of this table. It gets to the point 9/102. Well, it's not going to be real smart of me to go 9 right and then try to go 102 up without changing my scale. So let's think about that. Okay, for X, I can get to 9 pretty easy, but for Y, I got to get all the way up to 102. Maybe I should pick a scale where I'm going up by tens, and you can say I change that to tens for Y. All right, let's plot these points now. So once you have a scale, we'll plot the points. I got to plot the point 110, which I did here, 112, 333, 446. If I'm going too fast, pause the video as you do yours, because you can do this problem on your graph paper. 559, 670, and 9/102. I just created a scatter plot. Now when I look at the scatter plot, it's pretty obvious when I look at this, there's a positive correlation. These points definitely look like there's a pattern. It's rising from left to right. So the next thing to do is to draw a line of best fit. Now a line of best fit is a judgment call. You take your ruler and as best you can, you draw a line through these points which you feel best describes this set of points. So I'm going to do that. I took my ruler out and I drew that line. Now you notice my line isn't going to be able to go through every one of those points. I have to draw a line that I think, using my best judgment, is the best fitting line. That's a judgment call. All right, so everyone's line could be slightly different, but everybody's line should look like it's basically describing the pattern of these points. And now the last thing we have to do, remember, is write an equation. Now, this is where we got to be careful. I've seen people screw this up a lot. This is just a review of what we did early in the chapter. We got to write an equation. So, I wrote all my work. Let me get this out of the way. We have to write an equation. Okay, now to write an equation, we need 2 points on our line. Now this is a key thing. I need 2 points on the line. So it looked like the point 446, which I graphed, was on the line. But if I go right here, remember how this was the point 110 and this was the point 112? It looks like my line goes right in between those. So the point in between would probably be 111. So I'll call this point 111. I want to pick 2 points that look like they're on my line to find my equation. So I'm going to write an equation now. Remember, to find your equation, this is a good review since the test is coming up and we have to be able to write equations of lines. This is a good review of what we did early in the chapter. Step 1, get the slope. Maybe I'll write that up here even. Step 1, we got to get our slope. Find the slope. And you can see I'm doing that right here. I did 46 minus 11 for my y's. I did 4 minus 1 for my x's. That's 35/3. That's not pretty, but it is what it is. I take that slope and I plug it in for m. Okay, step 2. Step 2. I got to solve for b. Now remember, to solve for b, I can take either point and I can plug it in for x and y. I plugged in the one I thought was easiest. 1 for x, 11 for y. And I got to take away 35/3 from each side. Maybe I should write that down. I subtracted 35/3 from the right, and I took it away from the left. I can use my calculator in doing that. When I do 11 minus 35/3, remember when you put this in your calculator, put parentheses around the fraction. 11 minus 35/3 is negative 2/3. Well, there's my y-intercept. There's my equation. I just did all 4 of the steps that was asked, that we were outlined to do on page 326 regarding modeling a line to fit data. Okay? Now here's a common mistake that I see every year, and I want to make sure I put this in red. This is a big screw up. When we write our line of best fit, we have to pick 2 points that are on the line. It's very common for me to see people make this mistake, so I'm going to circle these in red. Look at these 2 points. If I use these 2 points, now by the way, these 2 points were 2 points on the table. Let me write them in red. They were the points 559 and the point 333. If I use those 2 points to write the equation for my line of best fit, my equation is going to be wrong. So let me show you this on paper. If I pick these 2 points to write my line, take a careful look at these 2 points. The line for these 2 points is this. And I'm going to try to draw this as neatly as I can. That's a little bit off. Let me try this again. That looks better. Okay? Are those 2 points going to give me the line that I drew in black? Is the question. And I hope that you're looking at this and saying, well, heck no, Mr. Lemansky, this line in red is way off from the line in black, and it is way off. I can't use points that are not on my line to write the equation for my line. I hope what I'm showing you here makes sense. If I use the point 559 and 333 to find the slope, my slope's going to be wrong, which is going to make my y, look at how far off this y-intercept is from what's in black. It's going to make the y-intercept wrong, my equation is going to be wrong. You must pick 2 points on the line. Maybe I should write that big in blue up here. In fact, I will, okay? You must pick 2 points on your line. On your line, okay? Not just 2 points that you graph. You got to pick 2 points on your line to write this equation out. Let's do one more problem real quick. Problem 13. So if you look at 13, it says make a scatter plot, describe the correlation of the data, if possible, fit the line to the data, and write an equation of the line. So if I do 13, first thing I got to do is pick a scale. So as I look at X, I'm like, wow, I got a graph from 10 all the way up to 99. So this scale, you know, if I just have a normal scale of 1, 2, 3, 4, and so on, it's going to take me forever to get out to 99. So maybe I'll pick a scale going by tens for X, and then look at Y. You got to get all the way up to 128. So if I pick a scale going up of 1, that's not going to work, and I have a negative, I got a graph too. So I decided to pick this scale. This is on my computer here, so I went by tens. Now my 128 is going to go a little bit off, but I'll have all the rest of them on there. Your graph paper would easily get up to 128. So I'm picking an appropriate scale. I'll go by tens for X and 10 for Y. Okay, so now I got to plot these points. So I'm going to do that. I have the point 10, negative 2, which would be about here. 12, 4 looks like it's about here. Again, I got to kind of estimate these a little bit. 15 right, 9 up. 20 right, 16 up. 30 right, 32 up. 45 right, 55 up. 60 right, 87 up. And then 99 right would be here, and 128 up, it's going to be up here. I can't quite fit it on here, but you could fit it on your graph paper. Okay, I got to draw a line of best fit. So I'm going to take my ruler out, and as best I can, I'm going to draw a line which describes this. Actually, that line's kind of crummy. I think I'm going to redo that line. I don't like it. So let me just get rid of this. I don't like that line. That's a crummy line. And I'm going to redo the line. I'm going to undo that, and I'm going to create a new slide, and I'm going to do a line. So let's do a new line here. I'm going to move this slide down. There we go. And let me do that real quick. I'm going to draw a new line, which I think better would describe that. why having the ruler would be helpful. I don't really have a ruler to help me with this, but that's not too bad. That line looks like it basically describes this data. Okay, that line describes this data. Okay, so now what I need to do is I need to write the line of best fit. Now, since I just changed my line, my work here is going to be off, so I'm going to change this too. Okay, let me erase this. I'm going to get rid of that. Okay, let's do this again. I'm going to get my line of best fit. I did, and let's write an equation for it. So to write an equation for it, I got to pick 2 points that are on this line. Okay, now this point looks like it's right on the line. I'll use it. That was the point 30 and 32. So I'm going to use that point. And it looks to me like the point, well, doesn't this right here, I'm going to circle it in blue, doesn't it look like right here, this would be the point about, I'm going to have to estimate, it's about 13.0. Would you agree? 13.0, or actually even better than that. I'm going to go down here. Let's forget about that one. Let's use this one. This is even better. What about this point? It's the point 0, negative 25. Let's use these 2 points to get my slope and y-intercept. Well, this is going to be easy now. My slope is 32 minus negative 25 on top. Let me get a thicker marker so that shows up better. It's 32 minus negative 25 for my y's. And my x's are 30 minus 0. And that would be 57 over 30. There's my slope. Okay, so I have my slope. Well, here's why I use this second point. Isn't that my y-intercept? Isn't when x is 0, my y-intercept negative 25? Well, then that means b is negative 25. Well, there's my equation. This line has a positive correlation. So since it had a positive correlation, I've got to spell that right, correlation. Since it had a positive correlation, I could definitely draw a line through the points, and I can definitely write an equation for that line. Okay? Now remember, my line of best fit might be slightly different than yours. That means my equation might be slightly different than yours. That doesn't make mine right and yours wrong. Everyone could have a slightly different equation because your line of best fit could be slightly different. Okay? I'm going to stop the video here. I think that gets us through what we need to see. And when you come in tomorrow, if you have questions, we can go through that more. Let me just, one more thing I see I forgot to write. Remember, step 4, we did step 4, write an equation. Write an equation for our line. And we did that. Okay, I'll see you tomorrow.